In this video, what we're going to do is to show some examples on how to prove that a quadrilateral is a parallelogram. Let us recall that a quadrilateral is any four-sided polygon, and parallelogram is one of them. But there are also quadrilaterals, and we call them special parallelograms because the properties of parallelograms are present also in those quadrilaterals. So those properties that make a quadrilateral a parallelogram are: we have number one, if there are two pairs of parallel sides, then that quadrilateral is a parallelogram. If the opposite sides of a quadrilateral are equal in length, then that quadrilateral is also a parallelogram. And number three, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is also a parallelogram. And lastly, if the opposite angles of a quadrilateral are equal, then that quadrilateral is a parallelogram. So what we're going to do, if there is a certain problem trying to prove a quadrilateral, trying to prove that it's a parallelogram, we're just going to show that one of this exists in that quadrilateral, and that we can conclude that certain quadrilateral is a parallelogram. So let's jump right into our problem number one. So we have here in the figure, ADB and CED are straight lines. Those are very important informations. Given that AD and CE, that's evident of the marking here, okay, and triangle BCD and triangle DAE are congruent, then what we're going to do, given that premise, we're going to prove that this ABCD is a parallelogram. Okay, so let us recall that when we say congruent, when two shapes or figures are congruent, meaning that they are exactly of the same size and of the same shape. Again, congruent figures are those figures which have the same size and the same shape, meaning consequently their corresponding sides are also equal, their corresponding angles are also equal. Okay, so what we're going to do is we are going to use this premise. So let's start our proof by stating our premise or our given. And we have that first. So we know that our statement on the left, then the reason on the right, then our first and second are our given stated in the problem. So AD equals to C, and the reason for that is that's the given in the problem, that's stated. Some proofs do not include the given, but in this case we include the given to show the coherence and connections of the concepts. So we have also triangle BCD is congruent to triangle DAE. So this is the symbol for congruent. So that's also a given. So what we're going to do is we're going to use this premise so that we will prove one of this. Okay. And after that, if we prove one of this, we conclude that it's a parallelogram. So what do you think? What do we think is our conclusion after this premise? If AD is equal to CE and triangle BCD is congruent to triangle DAE. So our next conclusion to that is here. This is equal to this. That's number 3. DA is equals to BC. Why are we able to conclude that? Because of number 2. Okay, We know that these two triangles are congruent. The BCD and the DAE, they are congruent, meaning, as I've said a while ago, their corresponding parts are also congruent, equal. So meaning, we have already this, DA and BC, meaning, oh, we already have one pair of opposite sides equal. So maybe we can prove this and this as also equal. Then we can conclude that it's a parallelogram. We also have ED and DB because they are parts of the congruent triangles. Look at this, ED and DB. So they are also equal. And it is also given in number 1 that these are also equal. Okay? By that, we can say using 3 and 4, we can conclude also that five and 6. So as you can see in 5 and 6, it's the conclusion after 3 and 4 because we conclude that DA equals BC in 3 and 4ED equals DB in 4. We can conclude that CE plus ED equals CD. So that's simply a segment addition postulate, meaning if you're going to add this one, this plus this is CD, and this plus this, that's AB. So that's segment addition postulate. Okay, so 5 and 6, if we use the 5 and 6 as a premise, what can we conclude? Here, number 7. Okay, so number 7, so if using 5 and 6, we can say that C, D, and AB are also equal. So if, because we know that 3, 4 supported by 5, 6, we can conclude that CD is equals to AB. So that is, what's the reason? Transitive property of equality. So what does it mean by transitive property of equality? If A is equals to B and another quantity B is equals to C, then A is equals to C. Okay, so that's common sense, right? If one quantity is equal to another quantity and that another quantity is equal again to the third quantity, which is C, sorry, this is C, therefore the first quantity and the third quantity are also equal. So that tells us here. So we know that using this concept, not really that one, this concept, AD and CE, and ED and DB, we can say that 5 and 6. Because of that, we can conclude 5 and 6. Okay, so if they are equal, and they are equal, and they are also equal, therefore they are also equal. Okay, so that makes our number 7 statement. That is because of transitive property of equality. So if we conclude, so look at this. We can conclude already let me erase this first, all of this. Okay, so look at this. The first is we were able to conclude that this one is equal to this one. That's number 3 statement. Okay, then in number 7 we concluded that, oh, this one is equal to this one. Those two statements, 3 and 7, are enough to conclude that, okay, Number 8 statement. ABCD is a parallelogram. Why? There are already two pairs of equal opposite sides. That's number 3 and number 7. So, as you see, we started from our given. Okay? We show that there are two pairs of equal sides using the help of this other statements. Then we conclude number 8. So that is simply how we prove quadrilateral being a parallelogram. Let's proceed with our next example. Okay, here, number 2. So we have, in the figure, PXQ and RSY, that's supposed to be RSY, are straight lines. Given that PXSY, this one, okay, is a parallelogram, and we have also this angle QRY and angle PSY are also equal. Prove that PQRS is a parallelogram. The same thing, we start with our premise. Okay, but let us recall first that it says that PXSY is a parallelogram, meaning in this PXSY, the four properties of parallelogram applies. Okay, the four properties of parallelogram apply here, can be applied here. So we will use that to conclude, to make deductions, so that we can conclude that PQRS are also equal. Okay, so again, the same thing, we start our proof with the given. So we know that PXSY is a parallelogram, that's the given. We know also that angle QRY and angle PSY is the given. Okay, so using this as a premise, if this is the premise, what can we conclude? Okay, what can we conclude? So let's take a look. Number 3. So we're going to look at number 3. This is the result of having number 1. Okay, number 1. Okay, so let me erase this first. Okay, so we have PXSY is a parallelogram, meaning PQ. Okay, PQ. So look at this. Let me specify it first. Since PXSY is a parallelogram, they are parallel. These two sides here are parallel, because as I've said a while ago, since PXSY is a parallelogram, the properties of parallelogram, the 4, applies in PXSY. We can apply that properties in PXSY. Not can, but we will certainly apply that PXSY in that parallelogram. So since we said that, oh, this one is a straight line, meaning we can extend this line as saying PQ, okay, and RS, because this is just one line, one straight line, RS as a straight line. So if 1, then 3. So if 1 is our premise, then we can include 3, PQ parallel to RS, with the help of this statement. Okay, so why is that? That's a property of a parallelogram. What's property? Opposite sides are equal in are parallel, so they are parallel, so this one is parallel. No, that's not, the marking is wrong, but parallel, arrow. Okay, so what other things we can conclude? Okay, using number 2, what do you think? Using number 2, what can we conclude? What's the use of this number 2? This one. Okay, we have number 4 statement. Because of the number 2, we can conclude that this one, that is PS and QR, are parallel. Why is that? That's the converse of corresponding angles postulate. Okay, remember that in your previous math lessons, if they are equal, these two angles are equal, therefore these two lines here are also parallel. So that's what we call converse of corresponding angles postulate. So that's the product of number, that's the, not really product, but the consequence of number 2. Conclusion for number 2. So if we use number 2 as a premise, that is our conclusion. And using this, look at this. Okay, look at this. Let me highlight this again. PQ is parallel to RS and PS is parallel to QR. That's enough to conclude that, okay, to conclude that number 5, PQRS is a parallelogram. Why? Two pairs of parallel sides. Okay, so we use, so again, let's recall, okay, let's recall the idea. If the premise is number 1, we concluded number 3. If the premise is number 2, we concluded number 4. If the premise is number 3 and 4, we concluded number 5. That's all for this video.